Okay, give yourself a couple of minutes, read this question, and then let's have a look at what it says. So it goes here, the question is, what they want you to do is show that the magnitude of the acceleration of each particle is 2.48 meters per second per second. So first of all, you've got forces going this side is 40 there, so it shows you that. It's also got a tension. Okay, so this, first of all, this is getting pulled up, so the tension is there, and as that's going there, you've got a tension that's pulling it the other way. Okay, so I'm going to call that T. Now, if the direction is going that way, it tells you it's got a friction. It's got a friction. Where was that? Magnitude force of friction here of 8 newtons. So if that's going that way, then the friction is pulling it that way, 8 newtons. Okay, so let's write the equation, what's happening at 3 kg, so at P. If I put the equation at P, what is happening? 40 newtons is pulling it to the left, and against 40 you've got 8 newtons to the right, and there's a tension to the right, and that is going to equal mass times acceleration. Mass is 3, and A, acceleration we don't know. Now let's look at the forces acting on Q. So the weight is acting down, so that's 2G, and the tension over here is pulling it up. So you've got the tension which is pulling it up, and the only force that is going against it is its weight, it's 2G, and that's going to be 2A, which is the mass times acceleration. Now what we can do, we can add these two equations together. By adding them, you get rid of these tensions. So what you end up getting is 40 take away 8 is 32 minus 2G equals, and if you add those together you get 5A. So the acceleration is going to be 32 minus 2 times 9.8 is the gravitational pull, all over divided by 5 equals 8, and if you put that in your calculator you should get what's required. A equals 2.48 meters per second per second. So that, I think that's nice, relatively straightforward, not a big issue here. Find the tension in the string. I'm just going to use this one because the tension is the same, so I'm going to use this one. So the tension is going to be T. Now this is minus 2G, so I'm going to take it to the side, so that's going to be plus 2G plus 2A. Now I know that's going to be 2, actually I'm going to factorize it, and G is 9.8 and A is 2.48. So I just factorize that. I'm just going to write it here just in case it's confused people. And that's just 2 times, if I add that onto that, I'll get 11, 12, 12.28 times that. So the tension is going to be 24.56. Again, I think that's nice. Nothing really too confusing about that. 7 marks, no problem. Okay, let's look at the next part of this. So it goes here, when balls have been in motion for 5 seconds, the string breaks. Okay, so what's happened here is the string has broken, so there's no tension. Find the additional time it takes for Q to hit the floor. Right, so let's just have a look at this. I'm going to probably move that here and draw a little diagram just to see what's going on. It's important that you do draw diagrams. Just helps you think about what's going on. Okay, let's just draw a quick diagram. So what we've got is we've got a scenario here or we had a scenario here, there's the pulley. This was being pulled this way and this was coming down, and the tension was pulling that up, and 2G, that was the weight, 2G was going down, okay, and this was 2 meters off the ground, and this was being pulled along here. Now when this was being pulled along here, we were told that the acceleration was 2.48 meters per second. We know that the time is being in motion is going to be t equals 0.5, and we know that well, we need to find what distance it moved, or what was the displacement. That's what we're looking for. And because we were told that initially it was at rest, we can also state that u is 0. Okay, so because it's constant acceleration, we can use that. And what I can simply do is, because I want to know what is the displacement, how much has this gone up, so that's going to be s equals ut plus half at squared. Plug those values in, so s will equal 0 times anything will be 0. That's going to be half times 2.48 times t is 0.5 squared. So if you put that in your calculator, you will get s equal to be 0.31 meters. So that means during the motion, this went up, this particle, this weight went up by 0.31. So now from the ground level, it is at 2.31 away from the ground level. Another thing that we need to, because we want to know, find the additional time elapses until Q hits the ground. So from there, it wants to know how long did it take from there to hit the ground here. So what we definitely know what the displacement, the height is from the ground. It's going to be 2.31. Now, we've been told that the tension has broken, the string is broken, so there's no tension. So this is now free falling. And if it's free falling, we know that it's coming down. Now, yeah, we'll give these signs in a second. We know it's coming down, so that is falling down freely, so it's coming down, the accelerate. So that's going to be just the gravitational pull, which is A equals 9.8 meters per second. Now, I'll give these signs in a second when I put the diagrams. Just give me 2 minutes, so we just get all these. And then, what else do I know? I want to find T, and what can I find is I can actually find what is the initial speed, and the way the initial speed is to find out what was the final speed when this was in motion, and that will be the initial speed of this scenario when it's coming down. So let's find, we've got all those, and let's see if we can find the final speed under these conditions here. So I've got 1, 2, I've got AT, UV, also got S, but I'm just going to use these figures here. So what I can do is, I know that final speed is equal to initial speed plus AT. So my final speed will be 0 plus time is a half seconds times 2.48, which will give me 1.24 meters per second. So that's going to be my initial speed. Now, before we plug all these numbers in, because I've called them all positive at the moment, let's have a look what's this going on. So we need to give it a direction. We need to know when is this particle going to hit this ground. Okay. So what we know at the moment is this is being pulled up in that direction. So if we're calling this gravity and we're calling this coming down, the pull is minus. The displacement, what we want from here, is going to be also minus because we're putting it in those two are in the same direction. And this is going in the opposite direction, which we're going to call positive. If you don't like that, you could call these two positive, and then this call this initial velocity negative because it's going in the different direction. It's 6 and 2 freeze, but make sure you're consistent in which you're putting these motions. So the motion, the U is pulling it that way, initial speed is going that way, and these are going in the opposite direction to that. Okay, so these are both going to be negative. So what you got here at the moment, let's look at the diagram. I've got a U, so let's use the diagram, the equation. S equals ut plus half at squared. S is minus 2.31. U is 1.24 t, and we're using the negative here, so half that is minus 4.9 t squared. If you bring all that to one side, you'll get 4.9 t squared minus 1.24 t minus the 2.31 equals 0. Now simply just put that in your calculator and solve it as a quadratic. And if you put that in your calculator, put it, you get two values. You'll get a 0.825, and you get t equals minus 0.57, etc. 1. But ignore the negative 1 because time can't be negative. Therefore, the additional time that lapses when this goes, when it hits the ground, t has to be 0.825 seconds. Okay, so we've done that one. Find the speed at which Q hits the floor. Okay, so that's the final velocity. We need to find V. Again, we can put all these same figures in and work out what V is. So I'm going to just use the simple one. When we got all those, we got so this is E. So you got V squared minus U squared equals 2AS. Now V squared I want to find out. U is minus 1.24 squared. 2 times, I'm using this, so that's a minus 9.8, and displacement is minus 2.31. V squared, if you add that to the other side, and just put it through your calculator, that will equal 46.8136, and if we square root that, therefore V will give me, freezing figures, 6.84 meters per second. So that's the speed it's going to hit the ground. We've done that. F, write down the magnitude of the normal contact normal reaction acting on Q when it's at rest. So very easy. E, when it's at rest, basically that is the weight, which is 2g, and Newton's third law, equal and opposite forces are equal, so Rn is going to be 2 times 9.8, which is 19.6 newtons. And last one, F. State one improvement that could be made to the model. A few different things. You could include any friction there is in the pulley. So in order to prove anything, you could have said that this string is parallel to the horizontal. Okay, there's a few things you could have put in there to improve it on. Okay, it's the one marker to put, see what's going on. You could even use a more accurate gravitational pull. I think in physics they use 9.81. So any of those. Okay, so I've just put there to mention friction and pulley, string parallel to horizontal floor, more accurate G. Okay.